All right, we're going to look at some complex operations, and what I mean by complex operations, we're going to deal with complex numbers here. Not like, hey, this is really difficult complex. This is just, we're looking at using complex numbers. So just a quick reminder, we've been doing stuff with square roots, and the reason why we've are doing complex operation is when we take the square root of, say, like a negative number, like -9, that creates a complex number, an imaginary number at that point in time. Because the definition of an imaginary number is the square root of -1. So the square root of -1 is I. When you see I as a number, it's a number. It's just representing the square root of -1. We just don't write the square root of -1. We use I instead. So this idea right here is like the definition of an imaginary number. I is equal to the square root of -1. So that's 1I. If I have something like the square root of -9, guys, that I could actually break that up into two different pieces. I could go the square root of 9 times the square root of -1. So, because if I times those together, that would give me -9 here. So when I go to do this, this gives me 3 and 3, which then I don't have anything inside, so this is just 3. And then the square root of -1 is just I, so 3 times I. So that's why we get I. So 3I is just the square root of -9, okay? If I had like the square root of, again, -4, that's just going to be 2I, because the square root of just +4 is 2, and then I have the I in the back there. If I have something that's not like a perfect square, like let's say we have the square root of let's say -16. Yeah, well, we'll go 18 actually. If we go to square root of -18, when I go and do this, I obviously, I mean, think about this. I can go the square root of -1 times the square root of 18, right? And then break this down, 9 and 2, 3 and 3. And I compare those up, cancel that out. The 3 gets on the outside and the 2 on the inside. Well, this is really just I, right? So this would be 3I square root of 2. So to kind of shortcut this, instead of like this is the reason why it's 3I square root of 2, but when I get like the square root of -24, I automatically know there's an I out because we've got that square root of -1. And then I take care of this positive one like we've been doing already for the last little while. I pair those 2's up, and then those can't go. So this is just going to be 2I square root of 6. So I just take the I right immediately. I know once I've got the square root, I'm going to have an I on the outside of that root at that point in time. Okay? And so that's where imaginary numbers come about. They come about because they're the square root of these values. You want to remember that I is the square root of -1. That's a really, really important fact. The other thing as we do some operations is what is I squared, guys? I squared, think about this, is just the square root of -1 squared, which hopefully in your head you've done that. It's just -1. This idea that I squared is -1, oops, sorry, -1, is another fact that I would not forget at this point in time. So we need to know that I is the square root of -1, and then I squared is -1 as well. Okay? Don't forget that idea. You're going to need it here in just a minute. So when we're doing complex operations, what we want to be able to do is add complex numbers. Now remember, these are imaginary numbers. Complex numbers are when we have a real and an imaginary number. So again, I have a real number plus or minus an imaginary number. So if I had like 3 minus 4I, that would be a complex number right there. I got a real and imaginary. I can't combine those. And so what we're going to do is do some operations with those. So I want to do addition, subtraction, and multiplication with you. So let's do that. Let's start with that. Let's say we've got 3 minus 4I, and we're going to add that to -7 plus 8I. When I add, it's a lot like adding polynomials, guys. Just add the reals, add the imaginaries. So this is going to be 3 plus negative 7, which gives me negative 4. And then negative 4i plus 8i, which is going to give me positive 4i. And that's it. So addition should be pretty simple here. At least I think it should be fairly simple with these complex numbers. So here I'm just going to add the 2 and the 5 together, which is going to give me 7, and then the I and the negative 6i, which is going to give me negative 5i. And that would be it. Subtraction works the same way, guys. Again, maybe if I use the same, I'll use the same complex numbers, but let's subtract them. I'm just going to subtract reals and subtract imaginaries. So for this one, I'm going 3 minus a negative. Remember, minus a negative becomes plus. So that'll give me 10. And then negative 4i minus 8i, which is going to give me now negative 12i when I go to subtract them. So you're just, again, subtracting reals, subtracting complexes at that point in time. So for this one, I'm going 2 minus 5, which will give me negative 3. And then I minus a negative, which becomes plus. So plus 7i is what I get from it. Bada bing, bada boom. That's how you do addition and subtraction. Multiplication. Let's just start again. Let's just start with this. If I'm going to take and let's say I'm multiplying just a real number to a complex number. So let's say we've got 7 here. In this case, I'm going to do like I've done with my polynomials and just distribute this and multiply it. I can't add real and imaginaries, but I can multiply a real to imaginary. So I'm going to go 7 times 3, which will give me 21. And 7 times 4i, negative 4i, which gives me negative 28i. And then I'm done with that one. So I just distribute. Okay? If I have, now be careful, if I have like an imaginary number, so let's say I have 2i, and I'm timesing it to my complex number. I'm still going to distribute that. This is going to give me 6i, because I'm just going 6, or 2 times 3, which gives me 6, and then put the I. And then here, 2i times negative 4i gives me negative 8i squared. Okay? Because 2 times 4 gives me 8, I times I gives me I squared. This is where you've got to remember the rule that we talked about, I squared being negative 1. This is negative 8i squared, which that's just negative 8 times negative 1, because this is really just negative 1. So negative 8 times negative 1 just gives you positive 8. So this will be a positive 8, and then I have my 6i. You probably ought to get in the habit, we always go the real and then the imaginary, so this is really just 8 plus 6i is what we really want to do here. Okay, the I squareds though, never ever ever leave. It's not simplified all the way if you have an I squared. You got to make sure that that's negative 1, which really just changes that sign. Okay, let's do another one like that. So let's say I have negative 4 I times, let's go 7 plus, actually let's go minus. Minus 2i. So I'm just going to distribute this through. I've got negative 28i and then plus 8i squared. I squared is negative 1, so this becomes negative 8 and then minus 28i from that. Bada bing, bada boom. Okay, the only other kinds is if you have a complex and a complex. So we have 3 minus 4i. And let's say we're timesing that to 2 plus 5i. Again, we're going to double distribute this and then simplify. It's double distribute. So 3's going to go through first. So that'll give me 6 plus 15i. And then I'm going to go to the negative 4i, which will give me negative 8i. And then negative 20i squared. Remember, this term, this 20i squared, is really just positive 20 because of that I squared, which then it can combine with the 6 to give me 26. And then I can combine the 15i and the 8i, which will give me positive 7i. let's do one more of those. So let's say we've got 9 plus I and 3 plus 2I. So I'm just going to distribute the 9 through first, which will give me 27 plus 18I, and then the i's, which will give me plus 3I plus 2I squared. This I squared is really just negative 2 because of that, which now combined with the 27, which gives me 25. And then I combine the 18I and the 3I, which will give me positive 21I. Bada bing, bada boom. Okay, that's it with complex operations. Adios.